Hello everyone, welcome to the channel. Today is Friday and it's Azure Friday. Today we are going to discuss about how do you manage the network in Azure. Specifically, our focus will be on the Azure load balancing technologies. There are various options in which Azure manages the traffic or the load balance using the different services. We'll discuss a couple of them. Let's get started. Here is our learning objective for today's discussion. Today, we'll try to understand the need of the load balancer, why it is necessary, and which scenario we should be using the load balancer. Next, we are going to discuss the difference between the different type of load balancer. If as I mentioned, there are different type of load balancing service available in Azure. So we'll discuss it, which of them are for which purpose. We'll also try to configure public or a private load balancer in our demonstration. So that's going to be interesting part if you have never configured a load balancer. And then we'll see some of the other services such as an application gateway, traffic manager, and so on. Let's get started now and see a scenario which demonstrate or simulate why do we have the need of Azure load balancer. Considering I have a web application which is being used by various users from their internet devices such as an desktop, computer, mobile, tablet, and other devices. So what typical user used to do, they try to connect to the website using their machine on the browser with both HTTPS or HTTP, and then the request basically go to the server or the public endpoints. When you type any URL, let's say https google.com, basically that URL bounds to a public IP address, and that IP address routes to a backend server. And that's where the Google or any application hosts their application software, and from there your request is being served. That's a typical journey of your request response delivery methodology, right? So, and when a request goes to server, the content gets delivered. That works fine if you are building a small scale application. But when it comes to the a large scale volume, when the volume goes high and high onto that server, the response received from the server, from the single server, is going to be challenging. To mitigate such scenarios, even in the on-premise situation, we used to configure the web form or the server forms. So form of servers basically, which is nothing but the collection of server, and then the same application which is hosted here on this particular machine or server, it is hosted on the other server as well, or the different form of servers as well. So similar to that, in Azure we have the services like Skillset, which offers the similar kind of a service wherein you can host multiple servers within that particular scale set or the availability set, right? And then within the availability set you can have the identical machines basically which host the uh, multiple instances of the machine which host the same kind of software. So now this time when the request comes to the to that particular web server, the request will be distributed amongst any of these servers. So these can be more than two servers, and it can go up to 1,000 of them depending upon the type of configuration you're choosing. When I talk about the cloud configuration, right? If I am in Azure and if I choose the standard or the premium version, then I can go up to 1,000 instance of virtual machine within the availability set. So this is where the typical traffic distribution scenario comes into the picture. Now, how the traffic is going to be distributed amongst this server. To distribute this traffic, we need a service which should be able to distribute the load amongst the server based on a certain rules, right? And for that, we have the service called the load balancer. So basically, a load balancer is a service which receives a traffic or which receives input from the end user on a public or a private network or on the, if I talk about the public load balancer, in that case it receives traffic on a public IP address and it distributes the traffic amongst the different backend servers based on the rules which you have defined. We'll look at that how those rules are looks like and how do you define the different rules so that it distributes the traffic. So this is how the fundamental of the or the topology of the load balancer comes into the picture. Moving on to the load balancers type or the options available related to the load balancer in Azure. Azure offers four different type of load balancing service. First of them is the public load balancer. In the public load balancer, basically it works on the OSI layer 4 traffic management topology, wherein it offers the load balancing based on the TCP or the UDP port. And it is useful, basically the public load balancer is useful to route traffic from the public internet to the Azure network. For example, in the case of public load balancer, as we have seen in the previous example, public load balancer will have the public IP address associated with that particular load balancer, and any traffic which is coming to the load balancer, it will be routed back to the Azure network. Next is the private load balancer. Basically, private load balancer and the public load balancer are same. The only difference is public private load balancer does not have the private public IP address associated with them. So the purpose of the private load balancer is to distribute the traffic which is being generated within the Azure virtual private network, and it distributes the traffic basically from one subnet to other subnet. Considering a scenario, let's say I have a virtual network with three different subnet. One is my web host, a web subnet, then I have a services subnet, and finally I have the third subnet, which is the database subnet or the data subnet. Now if I want to distribute a traffic from my web subnet to the data subnet, and I want to make sure any request which is being sent from my web tier or my web application tier to the service tier or from service tier to the database tier, it goes via the load balancer scenario, then I need to make sure that I have the load balancer services in place so that it distributes the traffic. In that case, I don't need to expose my load balancer on a public IP address on a uh, publicly as a publicly available service. So it is better to use the private load balancer. We'll look at it that how do you configure the private load balancer as well. Next one is the application gateway. Now the application gateway is the OSI layer 7 traffic management technology, wherein it offers some of the additional features on top of what we have on the load balancer. For example, it offers the SSL offloading, and it also has got the web app firewall capabilities. Why do we have the SSL capabilities or SSL offloading? Why? What benefit we'll get? The answer for that is when you offload the SSL at the application gateway layer, it means that any traffic which is coming from internet to your application gateway and it is going to your web application, then by offloading the SSL at the gateway layer, and request goes without having any SSL traffic to the web server, By this means that your web server do not need to perform the additional work. That means that your web server will get an extra throughput to perform the or to serve the actual request. So basically it is sharing the load or the responsibility of your web app not to offload the SSL, and it is saying, okay, you don't do this work, I'm here to help you out, and I'll be helping you to upload the SSL capability, and I'll validate the SSL certificate and upload the request and then send it back to you. So your job is to be more easy, and you will require only to serve the request which has been sent to you. And apart from that, it also got the web application firewall rules in place. So basically, application gateway comes as an OS configuration. So if I'm not wrong, it has got 3.1 OS configuration, version 3.1, and then it has got number of OWASP rule, which is a industry standard rule to validate your incoming request against all sort of vulnerabilities, whether it could be a SQL injection or it could be a type of kind of somebody is trying to hack with by sending a unknown request or a kind of hacking or attack on your web server, any sort of attack on your web server, then it tries to protect your web application or front end application from that sort of attack with the help of the firewall protection. So that's the thing it has got. Now when do you use the web application ahead of the public load balancer? So answer is, if you have the web application and you want to protect your web application directly accessing over the internet, if you want to protect that, then I would say you should have the application gateway wherein you get a better throughput by offloading capabilities if you have the SSL certificate configured for your web application. And also your web application now has got the firewall rule in place, which is going to be performed for each and every request. So that's where the scenario wherein you should be using that. Maybe in our future video, we'll try to look at the configuration of application gateway, but this is what the theoretical knowledge of this particular scenario. Now, next and the last one is the traffic manager. Basically, traffic manager is not a load balancer which balance the load amongst the Azure services. It is a kind of a DNS load balancer. Basically, it balance the traffic amongst the DNS server within the DNS server. For example, when you configure your website with the traffic manager, you try to configure on a, let's say when you try to implement a disaster recovery scenario for your project wherein your website is being hosted on North Europe region and South Europe region, and in that case, let's say your primary region is North Europe, secondary is uh, South Europe, and if you have configured the traffic manager, so what traffic manager will do, it will be a front facing for any request which is coming to your application. And what it will do, it will basically keep on checking that any request which is coming to the traffic manager, it will check which region is which region is currently active. If it is primary region is active, which will go and check in the DNS, and then if it is found healthy on the DNS layer, then it will redirect traffic to the primary region. Let's say due to some region disaster or manual failover, if somehow the primary region is down and your web application on the primary region is not available, in that case basically it will redirect the traffic to the secondary region. And again, it is a OSI layer 7 traffic management technology, and it they basically, as I mentioned, the use of this particular topology is to make sure that you when basically it is been used when you configure the disaster recovery or the geo replication or geographically load balancing of your DNS traffic from primary region to secondary region. Let's move on and have a look at the difference of the load balancing feature, as this particular discussion is more focused towards the load balance scenario or load balance topic. We'll discuss some of the different uh, SKUs feature between basic and standard. So there are some major differences between the basic and standard. So if you choose the basic tier of a load balancer, it is supported only up to 100 instances of the virtual machines or these servers which you are targeting for your load balancer. Next, it needs to have the single availability set or availability zone. You cannot choose a machine which is let's say machines which is one is from the availability zone ABC and other one is for availability zone XYZ. So it's not possible if you go for basic tier. And next, you cannot have the geo replication or zone redundant if you use the basic tier, right? So that's the major difference. And I would say if you are configuring the disaster recovery in your application, so it is not recommended to use the basic tier for Azure load balancer. So if you are from an architecture background, please do remember that. Next, here in while choosing the load balancing uh, SKU, uh, if you choose the basic one, it is energy is optional, but if you go for the standard, then you have to have the energy in place. Without that, I don't think Azure will allow you to create the load balancer in the standard mode. And if I compare the basic versus the standard, it has got the up to 1,000 machine supported. And maybe by the time you are looking at these videos, the configuration might change or the support services might change. So I would recommend you to go and check the services back onto the uh, Azure portal or Azure services on the load balancing section. And next is the Azure backend pool. Any VMs and any availability zone compared to the basic one, front end geo redundant is supported, and as I mentioned, energy is also required, which is mandatory. Now, next, look at the different component of your load balancer. So when you configure a load balancer, how what are the different components in which you need to configure, why those are important, and what roles they perform basically. Yeah, we will try to understand that. Don't worry, we are going to look at the demonstration. If you want, we can have a demonstration on the different topics as well, but all these things which we are discussing, we are going to have a demonstration about that. So let's look at the different component on the uh, load balancing. So in the load balancer, you have the first thing, you have the front end IP config. So as I mentioned, that load balancer uh, always work a public load balancer receives the traffic on the public IP address. So public IP address in load balancer called as an front end IP config or the front end IP, or the front end IP is built basically setting which holds the public IP address which is associated to your load balancer, wherein the incoming request or user is going to ping or route your traffic will be routed to this particular IP address basically. Yeah. Next is the backend pool, which is again the collection of machine which has been associated with your load balancing. So basically, where exactly your load balancer needs to route the traffic. So this is the where part of your load balancing configuration, which is backend pool. So I always remember backend pool as in where. Next is the help probe. Help probe basically tries to, you know, check the availability of your backend pool from the load balancer. So how many nodes are basically active and how many of them are disconnected. So backend pools basically keep on checking the healthy nodes and healthy backend pool servers with the help of back health probe configuration. So basically, how or where exactly, how do we need to check that? So basically this is going to be in that part. Now next is the load balancing rules. So load balancing rules is the rule or the configuration in the load balancing, load balance service, which defines how part. What do I mean by that is how your services or how your load balance is going to interact your backend pool, which is where part, right? So load balancing rule is the where how part, how your services or load balancer is going to be configured. How, I mean, what kind of rule it will have. For example, it might have a rule like, if traffic comes on the HTTP port 80 from this front-end IP config, then route the traffic back to this particular section, something like that, right? So this is going to define the how part. Next and the last one is the net rules. Basically, net rule is the interesting settings available in the load balancer, which defines how you can basically map one port to the other port within the backend pool. For example, let's say you have the load balancer configure and now you want to RDP to one of the virtual machines on the backend pool via the load balancer, right? So when you say, okay, load balancer public IP address this and port 3389, then load balancer will not know at which machine it should route to, because every machine will have the port 3389 available by default if it is a Windows machine, right? Now it will not be able to make a judgment that I need to route to which machine, right? Because there are multiple of them will be available. So in that case of, if you want to target any specific machine as a for RDP purpose, so what typically we used to do is we used to configure the NAT rule, and what we say is we define the custom port. Let's say I define a custom port as in 5000, and say if a request is coming from port number 5000, then redirect to machine number ABC or VM1 basically. Yeah. And if request is coming from 9000 example, and then redirect the machine my RDP request to machine number B or VM number 2. So this is where the NAT rule configuration comes into a picture, and this is how it is important to even basically map your port number from source to destination. I will repeat again, just to remind you to remember that this is how I remember backend pool. As I mentioned that it is a where part, how or where exactly your load balancer needs to redirect the traffic. Help proof is which application it needs to connect to, and then load balancing is what part is, or basically how part, and what it can do or how it is going to perform that thing, right? And then as I mentioned that it is going to be net rule is basically a port offloading. Yeah. Now let's look at the hash affinity logic in the load balancer. So basically hash is the encryption methodology wherein it encrypts some basically if you are a .NET programmer, you understand as in hashing is you pass usually hash some string to some encrypted character or is encrypted string so that it cannot be decrypted easily, right? So similar to that, when in the load balancer, when a request comes from the source computer to the destination via the load balancer, so it uses two different type of technology. First is the hash based affinity. In the hash based affinity, basically your four different tuples combine together, and basically load balancer tries to create an hash of it, and then it redirects the request based on the hashing methodology to the target server. For example, it uses the source IP, destination port, source port, destination IP, destination port, and the protocol, and then based on the whatever hash output it generates, encrypted output is generated, it redirects the request. Similar to that, there is another affinity service available, which is the source based affinity. In that case, it doesn't use the source and the destination port, but it just uses a source IP and the destination IP. So this one and this one. So that is called the source based affinity topology, in which it routes the traffic. So these are the two different routing topology. Now let's look at the demonstration. How do you configure the, first of all, the public load balancer? So if you are waiting for the demonstration, so where this is where we are, and now we are going to look at how do we create the public load balancer. So let me log into the developer uh, portal, or let me log into my portal.azure.com. So I've logged into my developer portal, and for this demonstration I've created one resource group, and as you can see, I have a couple of resources already created for you. Here you can see I have one availability set, couple of virtual machines configured inside the virtual network, and then I have the NSG which has got port 80 open for this demonstration. Now, if I go to any one of the virtual machine, as you can see, all the virtual machine has got just the private IP address. It means that if I am going to browse this particular virtual machine, I won't be able to browse it. For example, let me copy that and I'll try to browse it. Try to open that. And if I try to open like this, it's not going to work, right? Because it is private IP address and it's not going to recognize publicly. Now, if I go back, I don't have any virtual network or load balancer configured. So let me configure a load balancer. To configure load balancer, you need to search load balancer. I type in load and the load balancer comes in on the drop down. Here is the service, create this, and it is the resource group is selected where I want to create my load balancer. Now let me give the load balancer name as in demo LB03. Okay. Now region, you need to make sure that the load balancer which you are creating, it is in the same region wherein you have created your virtual machine. If you are creating the basic load balancer, for example, so all my resources are in the North Europe region, so that's the reason I am creating the load balancer in the North Europe, so that it finds the virtual network. I struggle a lot. By mistakenly I create the load balancer on some other region, and then I was trying to find out a resource group and I was not able to find that, so it was really difficult to figure it out what exactly went wrong with that case. So let me create IP as well. As I mentioned in the uh, demonstration, that it the public load balancer will require the public IP address, so I'm creating that as well. I'll just follow the naming standard and just give the prefix as LB, and then I'll keep it as an static for now, for example. Or you can create it dynamic, but the dynamic IP address will keep on changing. So let's create a review and create it. It won't take much of time. And as you can see, the resource is immediately created within just a couple of seconds. Now I have the load balancer available, which is again bound to this particular IP address. As you can see, at the moment there is no backend pool, help prop, or load balancing rule or NAT rule has been configured here. So we are going to go ahead and configure each of them one by one. As I mentioned, front-end IP address is the public IP address which has been associated to your load balancer. That's why you can see the public IP address available, and you will see the same thing here in the front-end IP configuration. Okay. Next is the backend pool, which is where part, as I mentioned. So now let's give the backend pool as a BP backend pool, and then select a virtual network. So this is the only virtual network which is created on my subscription on the North Europe region. So it has come as an selection. Now if I go ahead and select the virtual machines, I can add all of them. So select all the virtual machines. I've selected all of them. Once I click on add, I should have the backend pool created. It will take a bit of time. So I'll pause the demo and I will come back once it is completed. The backend pool is configured. Now let's configure the health probe, and I'll give the name as in health probe HP. And you can see as I've selected the HT basic load balancers, I have just got the option HTTP and TCP, whereas if I select the standard, then I will also get the option as an HTTPS. So this defines on this particular port, it will try to ping my backend pole on every 5 seconds, and then this is going to be the threshold for detecting as in failure. So basically it tries to keep on checking uh, whether the backend pools are healthy or not. This is what it does basically. I won't be able to create any other things while the one of the configuration is going on. That's the reason I paused the video in the previous section. So I hope this won't take much of a time to select or to configure the help probe. If you think I have missed something here in the demonstration, please let me know in the comment section. I will try to include in the updated version of the same demonstration. Or if you think that I need to have the demonstration of some other services which you would like to view, then I will be happy to create it. Let's see, the help probe is created. I got the message now. And next thing what we can do here is, let me see, it says it is available, but still it is saying the yes. Yeah, so it is updated now. Next is the rule set we are going to create, which is a load balancing rule, which again I'm going to call it as a rule 1. If you want to configure multiple rule, then that's okay. Now what we are saying here is, this is the for this particular front end IP address, and if you remember correctly, even in the load balancer you have the option to select multiple front end IP addresses. So load balancer is not something wherein you can configure a load balancer which will work on only one IP address, right? Or only one source of truth, or the IP address wherein the request comes into the this particular route, and then it will redirect it to predefined set of route. But you can have the multiple front-end IP addresses, and that's the reason there is a plus sign over there. I'll show you one more time. So here, that's the reason I have a drop down on this particular front-end IP address. If traffic is coming from this IP address on the port protocol TCP, then and the port number port 80, then redirect the traffic to the same port which is on port 80. If you want, you can go ahead and check for port 443, or let's say if you are in SQL, then you might want to configure for 1443, something like that. But this demonstration, we say if it is coming from this IP address on port 80, redirect my traffic to backend port 80, same port, and this is the backend pool which which we have configured, which has got 3 machines as you can see, and it will have the help probe which is going to helping you out to determine whether the nodes are active or not. So this is what the rule is saying, right? And this is the ideal timeout. If you want, you can have this session persistent if you want to keep it, but I'm going to leave it blank, none for now. Floating IP address, what it says, you should be configuring the floating IP address if you are configuring the load balancer for the SQL always on availability group. Basically, in the SQL on availability group, you configure the SQL failover cluster for your SQL servers. If you're not sure about that, please let me know. I'll create a demonstration wherein we will set up the entire SQL failover setup on the SQL as an Azure virtual machine, and then we'll try to set up the failover on the SQL server which is configured on virtual machine or on premise. Then we will you will get an idea how you configure the SQL always on the availability group and the failover cluster. So what this is saying is the floating IP you should only configure if you are configuring the SQL always on availability group and failover cluster. So we are not configuring that, so I'm going to leave it as is, and this is done. And if I go back, let's move on. It's, as you can see, it's still running, but I'll do one thing. I'll go back to the resource group, and meanwhile it is working, what I'll do, I'll check my virtual machine. And now you can see that earlier when we checked that our virtual machine has just got the uh, they got just the private IP address, but now you can see as we have associated our virtual machine to the public IP address, to the load balancer, it has got now the public IP address. And see what we should be able to basically redirect to this machine to. So earlier we tried using the private IP address and we did not able to do anything, but now you can see that's the beauty, right? I am able to configure the or ping my virtual machine or this IP address to VM number 1. So this is just a coincidence. So if you are on some any other machine, or if you are redirecting a traffic, or maybe I'll refresh it, then it might possible that it will redirect traffic to some other machine. Or if I try to type in the same IP on my any other device like my mobile or somewhere, then I might get the my traffic might be redirect to machine number 2 or 3 basically. Yeah, now let's try and do one thing. How test your net rule or health probe. So what we can do is, as our traffic is redirecting to machine number 1, so what we are going to do now, we will try to simulate a failure scenario. So in that case, to simulate a failure scenario, what we will do is we will shut down this machine. Okay, so what will happen now, we total there were 3 machines, now we got only 2 machines which are active. So now the load balancer should redirect to traffic to either of 2 available machine, and it should not redirect to uh, machine which is not available, which is machine number 1. So what I'm going to do now, I will try and go ahead and refresh this particular request. And as you can see, this is the wonder. We have got the traffic which has been distributed to machine number 3 now. I hope this is visible to everyone on this video. So this proves that we have successfully configured the load balancer, we have configured different rules, and now let's come back to the second demonstration, which is on the private load balancers. What I will do is I will go ahead, create new load balancer, load balancer here, create new load balancer, and here load balancer, I'll say demo command V, now demo dash lp dash 04. for example. Yeah. Here, when you say private load balancer, you say no, it is internal load balancer. You call private as an internal load balancer, which is basically going to help me out to redirect the traffic which has been generated from the virtual network itself. And then you say, okay, this is the virtual network and this is the subnet. So why, as soon as you get the, you choose this internal network, you need to choose the virtual network as well. Why? Because when you choose the public network, public load balancer, it is not going to ask you to create the choose the network, right? Because when you choose the internal, basically what it is going to do, it is going to create a load balancer inside a virtual network, and within that particular virtual network your traffic is going to be redirected between the different subnet. For example, let's say I have a SQL subnet wherein all my SQL virtual machines are I have SQL server configured on the Azure virtual machines with always on, and I have a dedicated subnet, data subnet created for that. So what I want is, I want my traffic to be redirected to the data subnet where all my data or the SQL machines are created, and I want traffic to be created only on the port number 1433, which is a SQL port. So this is how you can configure by selecting this. And you can see I just, as I flip the option, I get the different option, right? And choose the virtual network if I create, because it will select a private, it will require a private IP address to host this particular service, and that's why it is asking to choose the virtual network. Now next difference we will see here is the standard. As I mentioned in my theoretical session, that when you go for the standard, it has to have the NSGs in place in order to create the load balancing rule in place. Yeah. So you have to have the NSG created. Without the NSG, it is not going to work. So this is where the difference is. And the next difference you can see here is, as soon as I select from basic to the standard, I get an option to select an geo redundant availability zone. Basically, I need to get, I get an option to, because I can now switch or transfer the load across the different zone, whereas in case of basic I was not able to transfer the load across different zone. It was only applicable for a specific region. Yeah. So this is what the difference is. I'm not going to create this particular entire end-to-end flow, because I don't have SQL virtual machines or any other virtual machine where we can replicate the same scenario. But I hope this particular differentiation or the comparison between private and public from this portal will make sense, and you should be able to utilize that, right? Thanks for watching that. I hope this particular demonstration video is helpful. We will move on and look at the next demonstration or the next thing which we will discuss. Thanks for watching it. If you like it, please give it a thumbs up and subscribe to the channel. Thank you very much.